Hello everyone, and welcome back to my channel. This is Vishnu Manjipudi, and today we will be solving the 2018 AMC 8 problems 11 through 15. Let's begin with problem number 11. Abby, Bridget, and 4 of their classmates will be seated in 2 rows of 3 for a group picture, as shown. If the seating positions are assigned randomly, what is the probability that Abby and Bridget are adjacent to each other, in the same row or in the same column? This problem is very simple using elementary casework. We can assume that the other students are identical, and Abby and Bridget are distinct from each other and the other students. So we can label the other students as X's and Abby and Bridget as an A and B. So you get like an orientation would be something that looks like this, where the A and B are Abby and Bridget respectively, and the other 4 are the other students. Now, the probability is just the total number of successes, so number success, over the number of total outcomes. So to find the probability, we first have to find the number of total outcomes. Now, since the x's are indistinguishable, all we need to consider are the ways to place 1a and 1b in this grid, which is just 6 times 5 equals 30. So 30 is the total. And now we're going to find the number of possible ways. So without loss of generality, we can assume that Abby is either above or to the left of Bridget, and then multiply the final answer by 2. So we can get cases like this, where these lines are just 2 x's. Get this, or this for the vertical adjacency, and then for the horizontal adjacency, you can get something similar with A, B, and then here, then 2 x's. And then there's 4 positions, right? This one, this one, this one, and this one. So in total, that's 7 positions. But remember, we want to multiply by 2 since B could also be above or to the left of A. So that's a total of 7 times 2 equals 14 successes. Thus, our probability is 14, the number of successes, divided by 30, the number of total outcomes, or just 7 over 15. Choice C. Problem 12. The clock in Tree's car, which is not accurate, gains time at a constant rate. One day, as he begins shopping, he notes that his car clock and his watch, which is accurate, both say 12 o'clock. When he is done shopping, his watch says 12:30 and his car clock says 12:35. Later that day, Shree loses his watch. He looks at his car clock and it says 7 o'clock. What is the actual time? So, since both clocks say 12 o'clock noon accurately, when the watch advances 30 minutes, we know that the car clock advances 35 minutes. This means that the rate that the car clock gains time is simply 35 minutes on the car clock divided by the 30 minutes that passed on the normal clock, or the accurate time, which is just 7 divided by 6. Thus, the real time is 6/7 of the actual time plus noon. So, since it's 7 o'clock at the car clock, we know that 7 hours have passed, and 6/7 of 7 hours is simply 6 hours, meaning that the time right now is 6 o'clock. Choice B. Problem 13. Lila took 5 math tests, each worth a maximum of 100 points. Lila's score on each test was an integer, between 0 and 100 inclusive. Lila received the same score on the first 4 tests, and she received a higher score on the last test. Her average score on the 5 tests was 82. How many values are possible for Lila's score on the last test? For this, we can create a system of inequalities to determine the possible values of Lila's score. Let S be the lower score that she gets repeated 4 times, and then let L be the larger score. So the system of equalities and inequalities dictates that, first of all, since the average score on the 5 tests is 82, and the average score is just 4S plus L over 5, we know that 4S plus L is going to equal to 410, or L is equal to 410 minus 4S. And then the fact that she received a higher score on the last test means that L has to be greater than S. Or in other words, from this solved value of L, we have 410 is greater than 5S, or S is less than 410 divided by 5, which is just 82. Finally, our third inequality states that the score on each test is between 0 and 100 inclusive. So we know that 0 is less than S is less than 82, and we have S is less than L is less than 100. And this one's a less than or equal to. So this one's also less than or equal to. So now we can finally find the number of solutions. So since L is equal to 410 minus 5S, we know that 410 minus 5S is less than or equal to 100, or 5S must be greater than or equal to 310, meaning that S is also greater than or equal to 62. So now we have a range of S. S is between 62 and 82. And now is an important part of solving math problems, looking back at the answer choices occasionally. We note that this range actually gives us a value of 20, and 20 is not any of the answer choices. Looking back at our work, we see that we accidentally wrote 410 minus 5S, whereas in reality, L is 410 minus 4S. So let's just erase that. Okay, so we have 410 minus 4S is less than or equal to 100, which means that 4S is greater than or equal to 310, or S is greater than or equal to 310 divided by 4, which is also equal to 155 over 2. Since S is an integer, S must also be greater than or equal to 155 plus 1 over 2, which is 156 over 2, or just 78. Thus we know that S can be equal to 78, 79, 80, or 81. since 82 is not less than 82, giving an answer of 4. Problem 14. Let n be the greatest 5-digit number whose digits have a product of 120. What is the sum of the digits of n? Now, in order to produce the greatest 5-digit number, we need to maximize the first digit and then continue maximizing the next digits accordingly. This is because the first digit in the 5-digit number has the largest impact on the total value, and its value determines if it's larger or smaller than other values. So, let's first look at the factors of 120. We know that 120 is divisible by 1, 2, 3, 4, 5, 6, and 8. And these are just the single-digit numbers that divide 120 because we're looking at this by digit. So, it's easy to see that 8 is the largest digit here. So we put 8 in the front of our number. Now, the remaining product is going to be 120 divided by 8, or 15. So now, we do the same analysis, but with 15. 15 has one-digit divisors of 1, 3, and 5. So, we thus know that since 5 is the largest, we put 5 here. Next, we have the value of 3, and its one-digit divisors are 1 and 3. We put 3 here, and then we just have 1, whose only divisors are 1 and 1. So now we have our 5-digit number, 85311. The sum of the digits is simply 8 plus 5, 13, plus 3, 16, plus 1, 17, plus 1, 18. And finally, problem 15. In the diagram below, a diameter of each of the two smaller circles is a radius of the larger circle. If the two smaller circles have a combined area of 1 square unit, what is the area of the shaded region in square units? So, we use a fundamental property of area in similar figures. When a dimension doubles, the area quadruples. Since the two smaller circles have a combined area of 1 square unit, that means that the larger circle has an area of 2 squared multiplied by the area of one of these. And the area of one of the circles is just 1 over 2, 1/2. Multiplying this by 4, we see that the area of the entire large circle is 2. So since we know that the area of the entire large circle is 2, and the entire white area is going to be 1, the shaded area is simply 2 minus 1, or 1. Choice D, and we are done. Thank you so much for watching this video, it really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below, or email me at steamaspirations@gmail.com. This is Vishnu Manjipudi, signing off. Bye.